Okay, first question.
So about one data, you've mentioned on one slide, how does authentication authorization write permissions, especially in the sense of mounting the entire partition or whatever? That's at the root level, right? So it's not fuse file system. Or is that a fuse already?
Yeah,
so
it's a fuse file system, but okay. Then you get it's file system in user space.
Yeah.
And you actually get user space. So you have to a root needs to install Fuse, allowing all the users to use it, and then when you as a user install it, you get the right UID and GID of the user. And this is in fact a great question, because maybe later I can just give you some more technical details, because this is a broad, but we have this local user mapping thing that maps credentials in one data to credentials on the storage backends. And since the backends are different for every data provider and so on, it's pluggable, and you actually can query or LDAP, whatever, integrate Keycloak with what we want to translate your identity from one data to the UID and the GID on the system. And actually you will be, thanks to that, the files on the physical POSIX storage are written with your UID and GID. So outside of the system, you basically would have access to them on the file system, on the system level. And then when this is virtualized, we do the translation, and it's also yours. So pretty much this is how it works. And all the authorization is based on tokens. We use Google macaroons. These are tokens with contextual caveats. So we can limit the token. You can never make the token more powerful. You can only limit it. And all the stuff that's happening is using tokens. So if you want to mount, you just give your token. It can be limited to only see one file in your whole one data of ecosystem, one of the million files, and it will only show you the one file in your POSIX mount.
And did you have it deployed at any HPC? Because problem with Fuse, many people say performance, right? So is it performant enough to do?
Yeah. So we have, and basically we got good results. I mean, of course there is overhead, but usually it was low enough to be accepted, and in exchange you get the virtualization. So, of course, I wouldn't use this system if you have one site and you want to process the data, then, well, it doesn't make sense. But if you have 3 sites and the data is kind of replicated in a random manner, you want to move it, you want to process, this is the price you pay. So it's not perfect, but it's the best we got. And also the PyFile system plugin isn't bad, too. But, well, there is a certain price.
Thank you.
Other questions? Yeah, in the back.
Yeah, great talks, both of you. For JP, I was interested in how you were showing some variable level metadata. I think you had sex and age in there, for example. So I want to understand a couple things. First, are you mapping those to some kind of identifier, like Wikidata, to say this is what gender means, and then within gender, these are some possibilities? And then, did I understand that you're able to do joins across data sets? So you take gender from this CSV file plus, and then combine it with gender from the other, and other variables from another CSV file.
Yeah. So for the labeling of the variables, we pick whatever ontology is the best. And when I say the best, is the most used, the most maintained, the most common, so again, for the diagnosis aspect, we use the Snowmed CT for the moment. It's got a bit of a license problem, so we might move to Medra, but one of those two. For age, sex, so things, I can't remember which ontology, but there is a UID of and something that is very common and well maintained. That's the key aspect. I should emphasize that the system is not meant to label any data. It really is meant to think of the people who want to share things. So if you want to share some data across, different site labs or whatever, you have to agree on the data model that is useful for you. It doesn't mean that locally you can't, label many other things, and then when you try to retrieve data, you will get all those annotations as well. But for the search system, you want to search on things that are common across people, and and to me that's a community building aspect and tool almost. Like you want to create a community, and our first use case is mostly on Parkinson and neuroimaging. A community that is interested in that kind of scope, and we created a data model that is the most, what are the common variables that are required across, site, project and things on that community. There will be a community interested in, I don't know, like a monkey and electrophysiology. There will be the community interested in, many things. Hopefully, there will be some core variables that can be shared. But the key aspect is really you agree on the common data model. You ship that data model with a web tool that is, the zero install aspect, and you make it easy for someone who knows the data but don't know the, the link data technology, how to annotate with a link, So for the federated query aspect, it's a SparkQL, bunch. There's a REST API with SparkQL queries that are the most common queries that are extensible and things like that. And yes, you can do the SparkQL, whatever SparkQL can do, you can do. We implemented generic ones, and this is extensible. But yes, you can actually do a faceted query, across many variables. Yeah. Again, at the participant level, which I think was one of the key motivations, is recreate a cohort with all those distributed data sets.
Great, thank you.
Okay.
One data question. What level of history do you capture really? I saw that you talked about having snapshots. The question is, who does take a snapshot when? Or what possibly automatic process does at what point? And related to that, when you pointed out the archiving, that seemed to revolve around a single snapshot. Is that right? If I have several snapshots, that would be several archive packages, or did I get that wrong?
Okay, maybe I was too fast on this slide. Basically, so we have the idea of archives. An archive is basically a copy of the data from the data set stored on a long time on the long preservation storage system, and you can look at it as snapshots. So I kind of use it as a synonym. Of course, it's a bit, but they can be used as both. Of course, there's a different semantics to that. So basically, it's a copy, and it's a user choice to take a snapshot of their data set. So basically, this would happen when, for example, you have a living data set that kind of gets processed, annotated, and there is a release, let's say, and you want to just, keep this version and maybe publish it and keep it on a safe place that it's not going to be modified or anything, and maybe keep working, and in a month time create another one. So this is basically the idea. It's not automated by default, but you could quite easily automate it as you want, either using some middleware. We also have some. We have this automation engine that lets you define some repetitive tasks to be applied on your data, so you could have some kind of automated workflow to do it. Maybe run it every week or month, whatever. So if you want to use it more like backups, let's say, why not? It's possible.
Okay, thanks. That clarifies it. But then there's one follow-up. Those archive snapshots, let's call it, they are linked to some sort of dataset identifier, so I can tell what snapshots exist of a shared notion of a dataset?
Yes. So they are linked. So this data set is, we call it directory on steroids, basically, because not every directory, not every file in one data is a data set. You can say, okay, this directory has more of a special meaning, maybe some, I want this to be a data set, and it still works as a directory, but then it gets some extra features like blocking data modifications or something like that, or doing archive snapshots. And it's linked, so if the view I was showing, it was a view of a dataset and a list of archives inside it, and you know which archives was created when and based on which previous archive. So this is the incremental stuff. So you can see, okay, this one is based on this one, which is based on this one. And inside, we do it incrementally in a quite an easy, quite a simple way. We create hard links to files that haven't changed. So it's really only takes a bit of space in the metadata, but no extra disk space. But of course, if something changes, we create a new copy. So again, this is not a deduplicating file system, but yeah, this is how it works.
Okay, thank you.
Thanks.
Yep, a question.
For JP, the unification of metadata is a really hard problem. I think it's even harder on the file, let's say file type base, because it's really qualitatively different in like what kind of tests are unified, like memory tests, how close are they? Some consider them similar, some would not. So my question, as you were clear in that it's project-based, basically if it's a query from one side to the others to unify it, but do you track, my question is there, do you collect all these and are they cross-referenced? And basically because to make a it's limited to make a like a general unification, but there's still possibility inherent to collect them and make some more generalizable unifications. And I think that could be the more value overall building up. So do you have that in mind?
Yes, yes and no. No, it was not embedded in the system by default. By choice, so okay, we need to have that kind of thing. But when you label, so for instance, for the cognitive stuff, we use Cognitive Atlas. So when you label like in ontology, by default you have those layers of the hierarchical layers of ontology. So yes, at some stage, if someone is interested in any test on memory of things, you will get those. But we specifically try to avoid the link data problem. That is, let's label with the way we think is the best, and then we'll solve for the problem of multiple querying aspects later. We did the dumbest thing, and I think it's the right thing to do. It's to do the really dumb thing. You agree on the thing that is, and that's your local choice to call that thing that name. And that's something that will be shared as such. You can put all the other information next to that. But for the query system, and again, it's a query system problem. You want to have the same kind of entity being able to be queried, and whether then how you can reuse that because it's close enough or not close enough. That's a use case problem. It's someone will decide, oh, okay, that's not the same thing. I'm not going to take it. But at least at the query system, you'll have the so. Yes, you can, but it was not. That's not. It was not the primary kind of use case we want to solve. I think the key problem is still that people don't label their data, and until they have a super dumb and easy to use tool to do it, they won't do it. So that's the key problem. That's a social problem, and the only solution to that is a very simple and being able to demonstrate. Yes, when you do that very dumb thing, then look at what you get next. And that's until they see that, they won't take the 5 minutes to label their data. So I think we wanted to demonstrate that.
Do we have time for more?
Yep.
I have a follow-up. Do you think NeuroBagel has, or have you had some feedback from users to tell you whether it's dumb and intuitive enough?
Oh, it's very dumb, yeah. No. User feedback, at the moment, there's a lot of interest because of the local governance problems. So there's a huge interest because people want to have control and still be able to share, but they want to have control. Who do they want to share with, and what they can share, and especially in Europe, of course, with all the GDPR things, but also in clinical settings and other places. For instance, the Indian hospital we work with, they want to, they created that huge data set. They want to be in control of who's going. If they push that on Open Euro, let's say they can push that on Open, they will have 20 super well-funded North American labs that are going to analyze those data like crazy, so they spent years and they have little money. They spent years to create that thing. There has to be some kind of recognition aspect. So that infrastructure where you can see the data is visible, but the local people can decide, hey, yes, you would like to access my data, and let's make an agreement of how that's going to be used and what's the acknowledgement of those things. That has generated a huge interest for those like governance problem issues. The user feedback is for the moment is very good. Like the team has done a lot of work to make the tools very easy to install and very easy to use. The usual feedback is it's not extensible enough. Like it's the limitation is of making sure that it's small and limited. Is making it good and making it the thing that people want to extend. But we wanted to start with something that is very limited because of the adoption problem. No, I think the user. I don't know. Maybe Remy, you have a better idea, but I think the user feedback is pretty cool at the moment.
Okay. Thank you to both speakers. We're actually perfectly in time. So we'll wrap up the session here and take a 30-minute coffee break. And one more time, round of applause for our speakers.